Okay. All right, let me see. Everybody got their quiz back? Uh-oh. Nate. Sure. All right, guys. Any questions? Any other questions on homework? Can you be more specific? Any other questions on homework? 10-6. Which one? 123. So I hope you realize 123, it goes back to, they give you the formula there, right?
Yeah.
Okay. So in 123 in section 10.6, they give you this equation for how far you can see. Now hopefully everybody understands, the higher you go up, the further out you should be able to see on the Earth, because Earth is round. Any flat earthers out there? There's still a whole society of flat earthers. Oh, I took a picture of it from space, but it's still screw you. Oh my God, help us. So the higher up you go, so if you're on the surface of the Earth, you can only see, but if you go way up here, now you can see, much further until you hit that, and the higher up you see, the further you can see out. So they give us the formula. This is a rough estimation. From what I remember, this is really roughly true. So the higher you go up, you plug your height in, you can see how far out you go. And I think this H is in feet. So then they ask you on number 123, what height allows a person to see 20 miles? So what's 20? Which variable does 20 go in for? The distance, because I don't know what the height is. I don't know. What height would you have to attain to be able to see 20 miles out? As you look out, 20 miles out to the horizon, right? If you're standing on the beach, you can only see so far. But I want to go up until I can see 20 miles out, right? So what do I do? I plug a 20 in for D. How do I solve this for H?
Square root.
It's already square root, poor little dude. What do you do to a radical element? You first get it isolated, sure. You can divide by 1.22, and then how do you kill the square root? Square. All right. So just because it starts off with words and stuff, and you got to plug stuff in, once you plug it in, you're back in the earlier part. You just solve this equation. That's all that's good. Solve this equation. Yes.
Well, I have a different question.
Sure.
For number 45, I don't know.
In 10.6?
Yeah. I was trying to do, I know it's simple, but I don't know what step I'm messing
If
up
you do a good first step, this is still 10.6. It's got two radicals in it, right? Rad 2t minus 2 plus rad t equals 7. There's one thing you can do that would make this better.
Move over the square root of t.
Yeah, you can't isolate both, but you can isolate one radical, right? Right now they're both together. I could square, but then I'd have to FOIL this. I don't want to FOIL that. Well, you could. It would work. But it would look much worse than it has to. Right? So isolate as many radicals as you can. I can isolate this one. Now what do you do to both sides?
Square.
Because you want to kill that square root. What's going to happen over here? You got to FOIL it. Write it twice. FOIL it. Is that all right? Where are we at? Who asked that question? Did you try that?
So then it would be...
I'll do this side. That joke's getting old. I don't care. Keep doing it forever. Stand to half with it. You guys do that. How do you foil this? You write it twice so you don't forget anybody. Now you just foil it. Then what's going to happen? In the middle term, you're going to still have a radical. You're going to want to get it by itself and then square again. So it kind of should make sense. If I have two radicals, I'm going to have to square twice more than likely. So isolate one of the radicals, square, so you kill the radical. I've got one radical dead. Now when you foil this, what do you get when you foil this?
49.
49.
Minus 14.
Good. Minus 7 rad t minus another 7 rad t is minus 14 rad t. And what's rad t times rad t?
T.
T. Right? Square root of pineapple times square root of pineapple is pineapple. Makes a whole pineapple. And on this side it's not. And then what do I have to do now? Like I said, you gotta...
Like terms?
Sure. And all in order to get the radical by itself again, right? Whenever you do something to an equation, you kind of reevaluate where you are. What kind of equation do I have? I got an equation with a radical in it. What do? Get the radical by itself, kill it. So how do you get this radical by itself?
You have
Minus 49.
Minus 49. Minus t. So I get t minus
51.
51 equals
Negative 14.
negative 14 rad t.
Square everything.
Yeah, you don't have to divide by negative 14. You can just square right now, as long as you remember to square both of those.
So if you're squaring it, are you squaring the 14 as well?
You have to. If you square one side, you must square the other side. Both of these have to get squared.
So it'd be t squared. Take away.
Well, what do you have to do here?
Foil.
Foil it, just like we did earlier. You can never get away without the middle term here. You got to write it twice. Foil it. So you get t squared minus 51t minus another 51t
102T.
plus 51 times 51.
2,601.
Sure. Equals,
496T.
yeah, square that, square that. Ooh, this is looking yummy. You guys are going to like this one. Let me stop there. I mean, the important thing in any problem that I do is nothing about the specifics of it, just what told me what to do next. Why did I do what I did? At the beginning, I know I got to get a radical by itself. I got another radical. Oh shit, oh well. I get a radical by itself so I can kill it, and then I just get whatever happens on the other side when it's squared. I get another radical. Oh shit, I better get that radical mostly by itself. And then I square both sides. How do I kill a radical? I square to kill a radical. And then I just deal with the aftermath, right? Now what do I have to do here? What tells me what to do next?
Equals 0.
Why?
Because there's
Why do I get it equal to 0?
a X.
Because that t squared.
Yeah, good, because the t squared. I know you know it. It's okay. Yeah, so you want to subtract 196t, and then you're going to have just giant numbers to deal with, but oh well. Yeah.
So you always square that. You always square.
Why did I square? Bless you. Why did I square?
I know, that's you.
No, you said you always square,
Yeah,
but
you always square.
you don't always square. Why did I square? Because one of my variables is
It's
stuck in a square root. So how do I get it free? I do the opposite of what's being done to it. Do you see what I'm saying?
so you
The specifics about this problem don't matter. What matters is how do I see what to try next? How do I see what to try? I got radicals. Okay, I want to get one by itself and square because that's what's going to kill the radical and free up my stuff on the inside. When I do that, I still got a radical. Oh shit! Well, I got to get that radical by itself and square again. That's what tells me what to do next. All the numbers and shit that are happening are just kind of side effects. Okay, that's great. I got to deal with that. But what's telling me what to do is what's in the problem. All these radicals.
So you couldn't kill the radical right there on top?
I did. I killed one. I can't kill both. There's no way I can get both of these by themselves. One of them's got to be with that 7's like, come on, guys. One of them's got to be with the 7. That's all there is to it. Right? That sounded weird, but oh well. We'll work past it. Radicals laying with 7s. It's weird. It's the apocalypse.
How are we supposed to find the, like...
I don't know. That's gotta be gross. So let's see. When I subtract 196t, I end up with t squared
Minus 298.
Who is it? 298t plus 2601
Equals 0.
equals 0. Yeah, that's good. So I need numbers that do what?
Is it multiplied to 2,601 and add the 20?
Yeah, and we know what 2,601 came from, don't we?
Yeah.
It came from 51 times 51. So now watch, this is kind of another way to do this. I don't know what is happening outside, but let's just stay here. How do you factor 51?
17 and 3.
I like it. 3 goes in because 5 and 1 is 6. 17 times 3. 17 times 3.
Let's take out the 3.
Now watch this. Watch this. I should do a comma. Times. What's 17 times 17?
289.
All right, 289. And what's 3 times 3?
9.
All right, now do you see what I just did? I broke the number all the way down and then I recombined it in a different way. Because all I want are 2 factors of this. Well, how do I get factors of this? Recombine the prime factors of it in a different way. So look, 289 and 9, will they make 298? Yes, as long as they're both negative. They'll make negative 298. I mean, there's a whole other way to do this. There's a third method I hadn't even showed you until today. Because I didn't want to pile too much on you. But you can play around with the factors, break it all the way down, and then recombine them. And then see if the new combinations make what you need happen. That's another way to do it. Freaky. And then, of course, what do I do with these? Now here's where I don't care that the numbers are gross. Because I know, what am I going to pull out of this? What am I going to pull out? I'm going to have to pull a 9 out, because here I'm going to pull a t out, I'm going to left with t minus 289. So I got to pull a negative 9 out to make it t. So see, once you get these numbers figured out, the next step cannot be hard. It can't. Because the problem's telling you what's going to happen. So you know exactly, how do I make that t happen? I take a negative 9 out. And guess what? 9 times 289 is this, right? So 9 goes into that 289 times. I got to stop saying it like this. Sorry. And then... 2 equals there, so you can see your 2 answers, right? And then I got to go back to the original problem and see what was. Oh yeah, it was here. So yeah, you got to have to check those.
That's a ridiculous amount of work.
That's a lot.
Well, I'm just saying, like, because I did all the other problems, and I got all the other problems done on just one line. And
Well, then you should feel remarkably lucky about that fact. When
Yeah,
I'm going to
but-
be a complete dork for a second, that is not a lot. That is not. I'm sorry.
Well,
You're
no, I'm
worried
just
about the
saying-
big numbers, but you have ways to handle the big numbers.
I'm
You have
saying
a
it's a
calculator.
lot compared to the others.
Well, then be happy that the others are so quick. That's what I'm trying to say. Don't be upset at this problem just because it's the right length.
Oh, I'm
Be happy
mad.
the other ones work. Yeah.
I'm mad. What about 84?
All right, how's that? Is that all right? I mean, that's done. I did a problem for you. Be happy.
Thank you.
Yeah, 84?
Yeah, I don't understand.
Oh, sorry.
I still don't, like, I don't get how you put everything to the second power, like t minus 51.
Well, it was this, right?
Okay.
And then I square both sides. I'm allowed to do almost anything to both sides, as long as I do it to both sides. If I square both sides, it's still legal, right? But so why are you allowed to add 3 to both sides of an equation? Why am I allowed to add 3 to both sides? Because if I add 3 to both sides, it's still true. That's why you're allowed to add 3 as long as you do it to both sides. So what else can I do to both sides of an equation? I can square both sides of an equation.
Well, divide or multiply.
Or divide, or multiply, exactly, right? Or subtract. So of course I can square both sides. In fact, that's the whole thing that this method of solving is based on, is undoing what's being done. That's what I do in an equation. Whatever's being done to my variable, I do the opposite. What's the opposite of square root? Square. So I don't want that square root there, so I square both sides to kill it. Is that cool? I mean, that's the fundamental. How have you ever solved any equation? If you look back, you always did the opposite of what was happening. What did you do?
I tried to make the paper on the table. I'll pick it up.
Oops. Yes.
So, out of the answers, when I plug in 289, why does it not work? Because it equals 241 equals 7. So, is there a reason why 289 doesn't work into the original equation when you check it?
Your actual question is, why do I sometimes get answers that don't work?
Yeah.
And let me
I
remind you.
understand if they're like a negative or something like that.
Well, that's the thing. We didn't know. What is the square root of 289? All right. But you see right here, before I squared it, didn't it say this? Didn't it say this? Got it. It says it's right there. It says that, right?
Yeah.
Do I know what this is?
No.
Do you think the square root of 289, do you think it's bigger than 7? Square root of 289, do you think it's bigger than 7? Yes, you do. Yes, you do, because you're smart, and you know that's true. So 7 minus a number bigger than 7 is what kind of number? 7 minus a number bigger than 7 is what kind of number? 7 minus 10 is what kind of number? 7 minus a billion is what kind of number? It's a negative number, so it's saying square root equals a negative. Is that allowed? No. Did I know that at this point in the problem? No, I don't know what t is. I don't know if this is negative. So the math says, oh, you get 289, dude. That won't, you got to throw that out, because actually that would make this step impossible. So that's why you always have to check your answers to a radical equation. You guys understand that? That's a good question. Good time to reiterate that. That's why you get what's called extraneous solutions, right? Extraneous sounds painful. That word sounds painful. Extraneous. And it's not, you get answers that are wrong. You're like, math, screw you. And math's like, I'm sorry, man. I'm just trying to help you. Right, sorry. All right. Oh, there's yes. Sorry, you saw one of my colleagues.
Oh, so with number 45, are you just squaring like r to both sides?
This problem here? Yes?
No, number 45.
45?
You're talking about
84. 84.
84. All right. Oh, 84. Okay. All right, guys. So when the variable you're trying to solve for is inside of a square root, what do you know you will eventually have to do? You'll have to square it at some point. Maybe you have to move some stuff out of the way, but at some point you got to square that whole equation so you can free your variable up, right? So in number 84, what variable am I trying to solve for?
R.
Yeah, trying to solve for r. Where is r?
in the square root.
In the square root. Therefore, what do I have to do?
Square.
Yes. I mean, so see, that's the thing. What tells me what to do?
The square root.
Yes. In general in math, you focus on what's the process. Why would I apply that process? What tells me to apply that process? That is what's important in math. Yeah, so you square both sides. So then you get what? I'll do this. And that side's easy too. What do you get?
Plus r squared.
Yeah. Now you're just a couple steps away from solving for r. That's
Just
much
subtract L.
Sure, maybe. I don't know. I'll let you guys finish that.
I don't get it when it's letters though. If
It
there's
sounds like you do. You're doing fine.
yeah, but if there's numbers there, I can solve it.
But you're solving it right now.
So, but you take away the L from the so it's z. Is it L squared minus z?
No, come
squared
on now. What do you do to both
squared?
sides? What do you do to both sides?
Subtract L.
Subtract.
See, you got it. Don't assume things. Do it. So a lot of people don't write this kind of thing for themselves and they write things in the wrong way.
And I wrote it down.
Or I see a lot of people do this a lot. At 8x equals 4 and they tell me x is 2. What did that person do wrong? That is not right, by the way.
And the divider.
Because you're dividing by 8. You're not dividing by 4. So if you actually do it, you won't make that mistake. If you actually do this, 4, it's not 2. Holy crap, right? It's 1/2. Do you guys see what I'm saying? So a lot of times your brain just goes, oh yeah, that's going to happen. This is what's going to happen. No brain. Algebra is not hardwired into you, dude. Too bad for you. Let me do it so I can see what the hell's happening. So here I get what? What is z squared minus l squared?
Z2 minus L.
Z squared minus l squared. Yeah. Equals. And I got one more step.
Divide by the
Oh, don't
z
you?
squared minus L squared.
What are you trying to get by itself?
The R.
Why is it not by itself?
Because it's squared.
Because it's squared, so what do you do?
Square root it.
Get the root.
How do you kill the square? Because you just want R.
You want to
Square
square
root it.
You multiply it by
No divided by anything.
Square root everything.
Yeah, if you square root one side, you have to square root the other side. Whatever you do one side, you have to do the other side.
What the negative L? Is it just going to be square root of C to the second minus L to the second equals R? Or
Yeah. I mean, what happens when you take a square root? Now, I don't know if it says in this problem anything. No. So the minute I take a square root, what do I have to put? Plus or minus.
Oh, yeah.
All right, that's one thing. Right. So then what's this side become? R. And what's this side become?
plus or minus.
It.
Minus.
That.
that's what I think. You can't do anything with that.
Yeah, you can't. Good. You can't just make it Z minus L. Square root kills the square, Jeff. Yeah, but a square root can't do shit to a subtraction problem.
So that square root stays there?
Bam, yeah, because you can't do it.
But how do you get the plus minus in?
We know it's got to be there. That step involves the absolute value, which is why it's evil, right? Absolute value, I think I've already told you. Absolute value exists, it belongs there, we need it, but it's an evil function because it hides what it's doing. It says sometimes I do something and sometimes I don't. So that's why I got to put plus or minus, because give me a number that works for this. What's the number that works there? 4 is the obvious one. What's the less obvious one? There's another number that works. What do you square to get 16? 4 and negative 4. Negative 4 squared is also 16. See? So if you take a square root and you just say 4, you're wrong. Right? So you got to put plus or minus so you capture both answers. Right? We went through that. And that step is a conceptual step. It doesn't just come out, oh, you can tell the plus or minus. No, there's nothing algebraic there that happens. It's a concept. You got to get both answers, so you must put plus or minus. It's got to become second nature. The minute you take a square root, you got to put plus or minus. Now, what I was looking for is if they said R had to be positive or something, and then you can just take the positive answer, right? Like in a word problem. But they didn't say that, so you got to put plus or minus. Yeah.
So I had questions on 98 and 112. I feel like 106 and 112, that's essentially the same problem. So if I get help on 112, then I'll know how to do 106, right?
Oh, yeah. All right. I forgot these were in there.
And then 98, that I don't know if we learned that, did you?
Well, 98's old news. Just to remind you guys, in a right triangle, how do the sides relate? In a right triangle, let me call that AB and let me call that C.
Isn't it length times width?
That's to get the area of a square or a rectangle.
Oh, it's length times width times 1/2.
We're not getting a volume or an area. I want to know, how do the sides relate? Yeah, A squared plus B squared equals C squared. That's the old Greek dude, right? Pythagoras. And there was actually his followers that did most of his work, and he took the credit, but oh well, that's the way it worked back then. I don't know if you knew that. And I think I even showed, I can't remember if I showed you guys this, but if you put a square, like a square off the side of A, and a square off the side of B, and a square off the side of C, you add that area to that area, you get that area. So you are adding squares together. It's interesting. The A square plus the B square will be as big as the C square. That's a neat visual to keep in your brain to help you remember this fact. Now, why can't I just add A to B and get C? Because I would only add them if they were laying in the same, like if it was A and then here's B, then I'll add them, right? They're not, so it's got to be something weird. So that's what makes it work when you square it. There's like at least 128 proofs for the Pythagorean theorem. We actually had one of our Roosevelt presidents like to just prove it just for fun. It's a weird little side fact that you guys never needed to know, but if it comes up with Jeopardy, you're ready. So what the hell's it got to do with anything? Number 98 is that directly. What's the most important side? Most important side.
The long side.
It's the longest side. So I don't care which one of these I call A or B. They're interchangeable because I'm adding them. Who cares? But the longest side has to be the answer. Makes sense. If that's the longest side, it must be a combination of the two smaller sides. So you can't just put that. You can't. So if I have this, where does 7 go in the equation?
C.
Where does 2 go? Yeah, 7 goes in C. Where's 2 go? Who cares?
Either one.
You need that squared plus that squared equals, the important thing is that 7 ends up on it by itself. That's the what? That's the, what is that side? That is the
Longest.
longest. The hypotenuse. Hypotenuse? No? Hypotenuse? Remember that?
No.
I remember the word.
Yeah.
I remember the word.
Hypotenuse? Hypotenuse? Hypotenuse. Right? It's a medical condition. I got hypotenuse. Alright. And that actually is everything about number 106 too. If you read the book, they'll tell you what the distance formula is. But if I had a point, so you guys can survive this, x1, y1, and another point, x2, y2. And I want to know how far apart they are.
When you just do y2 minus y1 over.
No, that would be the slope. I want to know how far apart they are. I don't care about the slope. Slope has nothing to do with distance. It just tells you which way to go. It doesn't tell you how long to go that way. Do you guys see the hidden shape I've made here?
Yeah.
A right triangle. So if I know how long this side is, well, how long is that side?
1.
1 plus 1 squared.
Not plus.
No, minus.
If that was 7 and that was 2, how long is this? 5. So it's, and I know it's turned around, but I don't care. It's y2 minus y1 is this side. How long is this side?
Yeah, x2 minus x1.
x2 minus x1. And this side is the side I don't know. Normally I call it c. I'm going to call it d. Why would I call it d? Because now it means the distance. And variables don't matter for shit. Why did we call this side c? Because whoever came up with this, the Pythagorean people, they said, let's start at the beginning of the alphabet. Who cares? Who cares? Right? They call us d. It means the same thing. So now watch. So this is like side A is y2 minus y1. Side B is x2 minus x1. And side C I'm calling d. So what's the formula look like? It would be y2 minus y1 squared, right? A squared plus b squared.
Could you get the final answer and then square that, or do you have to
How
square
do
them?
you get the final answer until you've done this?
Well, no, I'm saying, like, would you do, because for example, 106 was x is -3 and then x2 is 2. So -2 take away 3 equals -5.
Where are we looking, sorry?
106.
Okay.
So would I
what's
square the
one point?
-5?
What's 1 point?
-3 and then +3,
Okay, -3, 3.
and then 2
And then
-2.
2, -2. I like it. So what do you put in here?
You're putting in negative, or you're putting in -2 and -3.
I like it.
And I'll
y2 minus y1 squared, because that's how long that side is, plus x2 minus x1, 2 minus -3, squared is my distance squared. So I think your actual question is, finish the side, and then the last thing you have to do is what? Square root, right? Because the answer here is going to be equal to distance squared. I don't want to know the square. How far away do you live? 400 square miles. No, square root the damn thing. Who are you? So get this side, and the last thing you want to do is square root both sides.
But so what I'm saying is, you do what's inside the parentheses
Yeah,
first,
order
and then you
operations
square.
never goes away. So you
Okay.
still have to do, this is not 4 plus 9. What did that person do? 4 plus 9. That 4 plus 9 person just drives me crazy. Where did 4 plus 9 come from? Can you guys see it? Can you guys be a teacher for a second and realize
Oh,
they
because
squared this thing, they squared that? That's crazy. That's completely against the grammar of math. The grammar of math says, no. Yeah. If you wanted to do that, you'd have to write it twice and foil it. Why the hell? The only reason I would ever foil anything is if I actually can't do what's inside. But I know what that number is. What am I squaring there? I'm squaring -5. I can square -5. If this was x minus 3, oh shit, I don't know what x minus 3 is. I better write it twice and foil it so I have a way to do it. If I could do the inside, screw that shit. -5. That's going to be
9.
5
Yeah, in general. Yeah.
5 squared.
squared. So I get 25 plus 25. Yeah. And then you take a square root. Cool. I like it. So there's some examples of that in the book. Good.
Because it equals d squared, then I would square d And
Square
then, I
root.
mean, square root
Square
D,
root.
and then square root
You
50.
gotta square root both sides.
Yeah.
That's a good
Okay.
answer. Now, why would you not put it plus or minus?
I don't know. That was what I was gonna ask too, because
What
that
does D represent? What does D represent?
Distance.
And can distance be negative?
No.
All right,
No.
there you go. It's a word problem. Math says either plus or minus numbers work, and we know math, but it's reality. We can't have negative distance math, and math was over. Weird little conversation.
So what's the result?
I don't know.
It's
So this is 5 squared is
In general, 25, the other 25.
5 squared is 25. So you get D squared equals 50, right?
Yeah.
Then you have to take a square root. You don't put plus or minus because you know it's got to be the positive one.
it'd be 5 and 2.
D equals square root of 50. I like it. Square root of 50 is 25 times 2. I like it. Good. So then you can simplify the answer. What's the units?
Points.
Were there units? No, these are just points. So there's no units. Yeah. Right. It didn't say they were miles apart or something. Yeah.
Well, I figured 112 is gonna be the same, so I don't need help on that one.
Good. 112 is the
But-
same.
My last question on this is 130.
Oh, what shape does that make?
Like a triangle.
Triangle. And what did we just talk about?
Triangles, it's a squared
Yeah.
plus b squared. Okay, so then that still applies for this one.
Any right triangle in the universe. The sides will have to be related by this.
And then c squared is always the longest.
C squared got to be the
Line.
longest one because it's made up the other two added. So it's got to be the longest one.
Okay.
I like it. Now, this angle. So right triangle means this angle is
90 degrees.
90 degrees is what the little box means, right? If that wasn't 90, this whole thing goes to shit. Right? There's actually an extra term you put on to make it true, but we're not going to do all that. Don't worry about it. Right. Pythagorean theorem is sort of a specific case for a bigger idea, but that's enough for that. Sorry. Okay. Anything else? Good. All right. So what I want to do is, I didn't end up saying we were going to have a quiz today. Yesterday I didn't say it, but still I have not a real quiz. Do you know me? Have you met me yet? I'm not going to give you a quiz when I didn't tell you I was going to have a quiz. It's evil. But I just want to give you what the quiz would have looked like. I want you guys to work by yourself for a little while, and then at some point I'm going to say group up and compare answers, and we'll see what happens. Yes?
Could we have a quiz maybe like on Wednesday or something just to help our grades?
Wednesday we have a test.
So we have a test on Tuesday?
Tuesday we have a review for the test.
Okay.
There's no time. Today was the last day we could have done a quiz.
I was just figuring, the more points, the better.
I agree with you. Some people don't understand that, but that's true. So do this by yourself first. Treat it like it's a real quiz, and it isn't. And then at some point I'll stop you. You guys can group up and compare answers.
Are we turning these in?
I'll figure it out. I don't know. Yes, sure.